Hello everyone, welcome to all for this today's session. In this session, we are going to discuss about draw the shear force and bending diagram for a given cantilever beam problem. We have already discussed overhanging beam as well as the cantilever beam, and here we are going to discuss for a special case of beam. The load is given is a different thing. So here the problem is given as it's a cantilever beam. Actually, a fixed end and another end is the free, but the load applied is a different one. It is a triangular load. Generally, this is called gradually varying load or uniformly varying load. Already uniformly distributed load is there, but it is uniformly varying because it starts with the see here at point A. It is starts with 0. That is the vertical height will denote you the intensity of load, but here it is starting with 0, so goes on increasing uniformly. It attains a maximum value of 2 kN per meter. That is called the intensity of load. So what is given here? Let's see the problem. We have to draw the shear force diagram and the bending moment diagram for a cantilever beam of AB, which is 3 meter long, carries gradually varying load, that is 0 kN per meter at fixed end to 2 kN at the free end. So that is the given problem. So first what we need to do here, we need to find what is the shear force value at the reaction value at A. We have to find, since it is a cantilever beam at fixed end, all the values to be supported by the same support. So need not to find whatever the total load, that is the value of the reaction at the cantilever beam. So how to find the total load? So here 0 to 2 kN per meter, since it is a uniformly varying load, how to find the total load? And also this kind of representation will give you the downward load that is given here. So the total point load to be calculated by the area of the triangle. So the area of the triangle, so total it is 3 meter and the vertical height is 2 kN per meter. So 3 meter and 2 kN per meter. How to find the area of the right angle triangle? It is nothing but half BH, half into base into height. So base is 3 meter, height is equal to 2 meter. By having the calculation, we are getting the point load as 3 kilonewton. Okay, so there is uniformly varying load having the total point load of 3 kilonewton. It is a downward load, but what is the location? That has to be identified. It is very important when we are dealing with the uniformly varying load. So the uniformly varying load, which is have a 3 kN at located at a point here, but what is the distance? It is nothing but from the maximum level. Here the maximum level is this end, because the perpendicular distance, vertical height is higher. So from this point it is 1/3 of the base, and here this remaining 2/3 of the base. Here base is 3 meter, so 1/3 into 3 or 2/3 into 3. So finally I can obtain, this is 1 meter, this is 2 meter. Okay, so 2 meter from A or 1 meter from B, that is the location of the total point load to be located. Okay, then how to find the reaction force? Then you have to find the shear forces, then bending moment. That's the thing. I already told only one reaction here at the fixed end here. So whatever the load is acting on, the same load will be the reaction load. So I already told it is 3 kilonewton is the total load acting. So RA is also equal to 3 kilonewton. Okay, so let's say by means of statically equilibrium conditions, I can apply algebraic sum of all vertical forces equal to 0. So only one load 3 kilonewton, which is downward. So RA minus 3 equal to 0, RA equal to 3. That's all. So no more reactions are there. So no more thing to be identified. Next, We can move on to the calculation of shear forces as per sign convention. Right, our downward is positive, left up is positive, right downward is positive here. So I can take this is at S of A. S of A to is left, it is equal to. So at left point you can take here. So you don't have any load at all. So 0 kilometer. Then you make a reference point here. You will have only one load in the upward. So left up is positive. So there is 3 kilometer at A at the right side. As well as let's go move on to the point B. Here also we can say left or right. You can take left side. So same thing. Only one load is there. It's also 3 kilonewton. If you go for the right side, there is no load at all. Okay, right side consider. So no load at all. It is also equal to 0. So simply it is being calculated shear force at A as well as B. Okay, then in 0 shear force line. This is the A to B is the 0 shear force line. Here it is 0 and this is 3 kilonewton. Then how to draw the shear force diagram here? Here, since it is in this region we are having a load, the type of load is UVL, that is uniform varying load. So parabolic curve you have to draw. So it is positive parabolic curve. You just touch these 2 points. Parabolic curve. This curve will indicate this parabolic condition, parabolic curve equation. This is about the calculation shear force diagram. Next we will move on to the bending moment. See here the number of beams being given with simply supported beam as well as cantilever beam. Uniformly there is overhang beam. This is also overhang beam with UDL. So whenever it is there, this end conditions at A and B, if you consider all MA as well as MB both are equal to 0. Here MB is equal to 0, but MA is not equal to 0. As well as here at MB is equal to 0. And here MA is equal to 0 and here MB is equal to 0 at the end. So except this fixed end, all the end conditions, the bending moment will equal to 0. So this is the thing we should know. But what is the statical equilibrium equation, third boundary equation thing? But algebraic sum of all bending moment, all forces acting on the side of the section, that is equal to 0. Okay, now let's move on to the point B. Here, as I said, here is a overhanging beam. Here at point B, okay, end condition equal to 0, but at point A it is not equal to 0 because this is overhang. Sorry, it is a cantilever beam. Okay, so what to do here? The bending moment at A, we can find that the total load 3 kilonewton. Okay, and because we don't have this RB and all, okay, simply we have only one load. So this load into perpendicular distance. So 3 into this is 2 meter. And what is the sign convention for calculation of bending moment? Downward force create always negative bending moment. So 3 into 2. So this is 6 kilonewton meter. Hence it is downward force negative bending moment will create. Okay. So this is a simple case of diagram. Simply only one point and another point. We already know that the end condition of B bending moment equal to 0 and here it is equal to 0. And draw this here bending moment 0 bending moment line. Here it is minus 6 in the bottom. So you draw, you touch down how to the curve will be. That is the thing. Here shear force diagram, which is parabolic curve, it is cubic curve. That means x cube plus 2x squared something. That kind of equation it will obey. So this is about the bending moment diagram for the given cantilever beam. Sorry, for the overhanging beam with the uniformly distributed load. We will see in the next class with a different type of beam to find the shear force and bending moment diagram.